So in this video, I'm going to solve the differential equation that's been given here, and we have an initial condition with which we can use as well. So looking at this equation, I can see that it's first order because I've only got a first derivative appearing in the equation. And looking at it as well, I think that separation of variables is going to be a good technique to use in order to solve it. That's where you split the variables across the left and the right hand side of the equation. So in this context, we're going to have v as one of our variables, and if we look through the equation, there's no other v's. So it's going to need to be on one side. And then our other variable is t, and we can see that appears in a couple of places. So that means that all of these terms with t in them are going to have to be on the other side of the equation. So let's go ahead and do that. So I'm going to leave the dv here on its own, and I'm going to shift the dt up to the other side. Okay, so I can see that I've definitely separated now. We've got all the v's on one side, all the things with t on the other. So now what we can do, going along with this separation technique, is we can integrate both sides of the equation. Now this one, it's a little bit tricky. The catch is you just can pop a 1 in there if you want to integrate with respect to the number 1. Remember, multiplying by 1 doesn't really do anything to your equation. So now I'm going to integrate this side with respect to v. All right, we can see the little dv in here. And the integral of 1 with respect to v is just going to be v on its own. We now need to integrate the other side of the equation, and this is with respect to t. All right, we can see that here. All right, so this one, integrating it, we know the integral of cos is going to be sine, and we keep whatever's in the bracket. And what we're going to need to do is divide by the derivative of what's in the bracket. This is like applying the chain rule in reverse. So that means I'm going to have to multiply by a half or divide by 2. Okay, if you want to check whether this is the correct correct integral, what you can do is take the derivative of this, and it should go back to cos of 2t. All right, so now we need to integrate 1 with respect to t, and we know that that's just going to go to t on its own. So we've performed indefinite integrals here, which means that we're going to end up with a constant, an integration constant falling out of the equations. Now, if you want, you can put 1 on both sides, but really you only need to pick up 1 because they're going to end up tying into each other anyway. So that's what my little plus c is on this right-hand side. Again, equally, you could have put it on the left. It doesn't really matter. All right, so this is the kind of general solution to the differential equation, but what we've been given is this initial condition. So with the initial condition, we should be able to figure out what c actually is. So what this is telling us is that at t is equal to 0, right, with this 0 in here, v is equal to this 0 on the other side. So let's pop this into our equation. So we're going to get 0 here is equal to a half sine. It's going to be 2 times 0 plus c. So looking at this, sine of 0 is 0, so that's going to disappear, and we've got 0. All right, so that disappears as well. So all that we're going to end up with is c is equal to 0, so that's our integration constant. So that means that we can write kind of the final version of our solution, including our integration constant c. All right, so it's going to be plus 0, so I might just leave it off. And that would be our answer to the equation. Now, if you want to, you can actually look at what this looks like. And I've plotted it in Wolfram Alpha here. So this is the plot of our solution between t equals 0 seconds and t is equal to 10. And you can see that it starts at the point 0, 0, which is a good check for us, because we know that our condition was at t equals 0, v had to equal 0. So if we did that check and we saw that it wasn't starting at the same point as what we expected, then that would be a flag to go back and check what's gone wrong. So that's pretty much all there is in terms of this video.